All right, this section is 1.7 inequalities, and so for this one, we're going to start off with some linear inequalities, which is an inequality with all the variables in the first degree. These ones you've probably done before, so we just isolate the x here. So in this case, I'm going to subtract the 9x over to this side. So negative 6x is less than 4. So then I'm going to divide by negative 6, and remember on these ones, anytime we divide by a negative, we really need to flip the inequality, and so this is going to become x is greater than negative 2/3 if I go ahead and reduce that fraction. All right, we do need this in interval notation, so I'm going to go ahead and draw it on the number line first. So we have negative 2/3. There's an open circle, and it's going right forever. So in the interval notation, that would be negative 2/3 with a parentheses to infinity. All right, and then same idea with this one. This is actually a compound inequality. So when I add 2, it's just like I have to add 2 to all three sides. So we have 6 is less than or equal to negative 3x, which is less than 15. And then I'm going to divide all three sides by negative 3. Now, same rule here. If I divide by a negative, I have to flip this sign. So this is going to be negative 2 is greater than or equal to x, which is greater than negative 5. So in this case, I kind of just think of it like x is in between negative 2 and positive 5. And so if I were to draw that on the number line, we have negative 5 and then negative 2. Negative 5 is an open dot and negative 2 is a closed dot. So we'll have parentheses negative 5 and then negative 2 with a closed dot. All right, so next up here, we're going to move on, and now we're actually going to do nonlinear inequalities. So nonlinear inequalities we see is an inequality with a variable to a higher degree. So we have some second degree here. On the next page, we'll have some third or fourth or fifth degree, or with variables in the numerator and denominator of a rational expression. So the steps for this one are very different. You're not really just isolating x. You're going to get one side to 0. You're going to factor. And then on a number line, you're going to put all the values that make the expression 0 or undefined. That's what I meant there for be undefined. And then after that, you have two options. So the traditional way to do this is to test values in the gaps to see if they make the expression positive or negative. But option 2 is sketch a graph of the function with the correct end behavior to see where it is above or below the x-axis. So I'm going to do both of these on the first one here. But I think you're going to see that option 2 is kind of the easier way to do it. So that's the one I'm going to be mainly using. And that's why we did this after we learned about end behavior and graphing, because it makes this a lot easier. So let me try out number 3 here. So we're going to get one side to 0. That's actually done for us already. And now we're going to factor. So on this one, I'm thinking of two numbers that multiply to 6 and add to negative 5. These are always tricky with the 6s and 5s. I think this one's negative 2 and negative 3. That multiplies to a positive and adds to a negative. That's good. Since I don't have an a value here, I can just rewrite this as x minus 2 times x minus 3 is less than 0. Now what's really important here, what I don't want to do next is split this up and set them less than 0 individually. That will not give me a correct answer. Instead, I have to do step 3 here, which is on a number line, put the values that make the expression 0 or undefined. So it's kind of like graphing the zeros on your graphs on the previous section here. So I'm going to put 2 and 3 there, okay? And you have to put those in order. And so 2 is obviously smaller than 3. And then I can put open dots here and here. I know I can do that already because of the less than sign. So just remember kind of our faces of inequality. They're going to be popping up here in a big way. So that's this guy, and later on we'll have some of this guy. So that'll be the closed dot in the bracket there. Okay, so I'll kind of do this now. Why don't I do this as option 1, because you will see and so I'll put a little green dot here, and I'll do this as option 1, and then I'll show you how it's kind of much easier to do this as option 2. So for option 1, what you would do is they have you go inside of each one of these gaps, and they just pick a number. So over here, I could pick like x equals 0. In between here, I could pick like x equals 2.5. And then over here, I could pick something like x equals 4. And you plug it into these parentheses. You plug it into the x minus 2 and the x minus 3. And all you care about is whether it's positive or negative. So if I plug in 0 for x, and I'm showing it in this parentheses here. 0 minus 2 would be negative, and then 0 minus 3 would also be negative. And then we know a negative times a negative is a positive, so they say this zone is positive. In between here at 2.5, if I plug it into the parentheses, 2.5 minus 2 is positive, 2.5 minus 3 is negative, and then a positive times a negative is a negative. Lastly, x equals 4 if I plug those into both parentheses. 4 minus 2 is positive, and 4 minus 3 is positive, and a positive times a positive is a positive. So that would tell me that the middle zone is negative and the outer two zones are positive. Now, if we were to do option 2 here, sketch a graph of what it looks like, if I kind of visualize this, either way I look at it in the factored form or the standard form, we have a degree 2 positive. And so I know that the arrows are going to go up to the left. And I'm going to go ahead and draw that right over the top of this. So we have a degree 2 positive. And so this is going to go up to the left and up to the right. Those are both cutting x-intercepts, so it's going to cut below the x-axis and then cut back above the x-axis. So what you can see here is wherever it's above the x-axis, that's where our positive is. And wherever it's below the x-axis, that's where our negative is. And then again with the positive over here. So it gives us those same results, okay? Because what we're looking for is here is where is it positive, where is it negative, which on the graph is where is it above the x-axis versus where is it below the x-axis. Now, the last thing we need to decide here is what do we want? Do we want the positives or do we want the negatives? And I get that from this right here, less than 0. We know that means I want a negative. Or if there's multiple negatives, I want those. So where is it negative? Well, that would be between 2 and 3 here. And so I'm going to kind of color that in. And so if I write my answer here in interval notation, it would be from 2 to 3. So that would be my answer there. Where is that expression less than 0? Where is that expression negative? Where is that expression underneath the x-axis? It's when x is between 2 and 3. But with parentheses because not at 2 and not at 3. All right, next up here, we'll take a look at number 4. And from now on, I'm actually just going to be sticking with option 2 here. Like I said, I think that's the easier way to do this. And so I'm going to get one side to 0 first. So I'm going to do step 1. So I'm going to add the 48 over to the other side, and I'm going to subtract the 14r. I usually like to isolate the variables on the left-hand side of this. I think that's always easier. And I'm going to put this in kind of the standard form here. And this is greater than or equal to 0. Okay, and so now I'm going to factor. We're thinking of two numbers multiplied to 48 and add to negative 14, which is negative 6 and a negative 8. And then once again here, no a value, so I can just call this r minus 8 and r minus 6. And so now I'm going to go to the number line here, and we'll put, even though I have those in the other order, we have to put it in order down here. So I'm going to put 6 first and then 8. These in this case are closed dots, thinking back to our faces of inequality because of the or equals to. And then I'm actually just going to go ahead and graph this. So we know that this is, again, another degree 2 positive when I'm looking at this step right here, or this step right here. And so that's going to be like a positive parabola, and it'll go through the x-intercepts there. And so I know that this is going to be a plus, this is going to be a minus, and this is going to be a plus. Now, what do I want in this case? In this case, because we're greater than or equal to 0, that means I want the positives. And so I want all the zones over here, or I want the zone over here, and I also want the zone over there. I do not want the zone in the middle in this case. And so in this one, my interval is going to be from negative infinity to 6 with a bracket, and then 8 to infinity. Of course, the infinities are always parentheses, but on the 6 and the 8, those should be numbers. So I'm skipping over that space in the middle again because that is beneath the x-axis. That is negative, and I don't want that. I wanted the positives on this one because it's greater than 0. Greater than or equal to 0. All right, next up, number 5. Once again, we will get one side to 0 here. So I'm going to subtract the 4w, and I'm going to subtract 3. So we get 4w squared minus 4w minus 3 is greater than 0. And then, what do I want? So I'm going to factor this. So we're going to think, now we do have an a value here, so that's going to make this a little tougher. A times c is negative 12. On bottom we have negative 4, so that's negative 6 and positive 2. Now, since I do have this a value here, I need to use my grouping technique. So I'm going to rewrite this one, 4w squared, and then split this up according to the x. So we have negative 6w and positive 2w, and then minus 3. Now we'll group up our terms here. First group, I can take out a 2w, which leaves me with 2w minus 3. The second group, it looks like I cannot take out anything, and so whenever that happens, I take out either positive 1 or negative 1. In this case, it's a positive 1. And so I end up with the same thing in both of those parentheses, which is good. So now my factored form is 2w plus 1 times 2w minus 3, which is greater than 0. So now I need to go to my number line here and draw both of those. So I have negative 1/2 and positive 3 over 2. I did that in my head, but if you're not sure how I did that, we set those equal to 0, and then we move this one over, so 2w equals negative 1, and then divide by 2. So that's the negative 1/2, and then 2w plus, nope, that one's minus 3 equals 0, so 2w equals 3, w equals 3 over 2. The negative 1/2 will go on the left because it's smaller. Obviously, a negative will be smaller than a positive. And now I'll draw my graph. This is yet another, whether we look at it here or here, it's a degree 2 positive. So another parabola here. So we're going to go like that. And then what do we got here? Open dots. So we have a positive above the x-axis, a negative below the x-axis, and then another positive above the x-axis. In this case, because I am greater than 0, whether you look at it there or there, that means I want the positive. And so I want the zone over here, which is positive, and also over here. So my interval notation on that one will be negative infinity to negative 1/2, and then from 3 over 2 to infinity. All right, next up, number 6. So for this one, once again, I want to get one side to 0, so I'm going to subtract the 18. So 2x squared minus 18 is less than 0. I'll go ahead and factor this one. I actually see a GCF here, so I'm going to take a 2 out first. And then we'll go ahead and factor this as the difference of perfect squares. All right, so what's going to make this 0? Well, I think it would just be negative 3 and positive 3. I wouldn't put anything for that 2 out front since there's no x there. It does not create an x-intercept. And so once again here, we see that this is a degree 2 positive. And so we have another parabola here. We are going to get to the next page where they won't be parabolas, but in this page they're all parabolas. Open dots there, which means we're above, below, and above. Okay, and so what do we want on this one? We want the negatives. And so I'm just going to say from negative 3 to 3. See that negative space right in the middle. All right, next up, I'll do number 7 here. Along with it, since it's a good comparison. So I first need to get one side to 0. So even though you can factor x squared minus 5x plus 4, don't do that yet. We only factor when one side is 0. Okay, so I got that side to 0, and now actually the only factoring I can do is GCF. So I'll do that. And so now on my number line, I actually have a 0 at 0 because I have an x GCF'd out front. And then also for 5. So these are closed dots here. But I still have that degree 2 positive. Once again, whether we look at it in the factored or the standard form, it's degree 2 positive, which means it's going to look like a parabola. So I'll have the plus, the minus, and the plus. All right, so what do we want on this one? We want the positives. And so I want the outsides in this case, so negative infinity to 0. And then 5 to infinity. Remember, negative infinity and infinity always with the parentheses. All right, next up here, number 8. Once again, I want to get everything to one side, so I'm going to add the 24x over here. And then we'll write this as negative 2x to the third minus 2x squared plus 24x is less than 0. All right, so now we're going to factor this. I see a GCF first. I'm going to take out a negative 2x. Which is going to leave this as x squared plus x minus 12. Remember, when you take out a negative, it's going to flip the signs of everything. All right, and so now I'm going to factor this, thinking of two numbers that multiply to negative 12 and add to 1, which would be positive 4 and negative 3. I have no a value here, so I don't need to use the grouping technique. I'll just go ahead and write it like this. So now we'll go ahead and go to our number line. So the numbers I need on there, I need -4, I need +3, and then I need 0. Remember, whenever you have the x GCF'd out front like that, you are going to have a 0 at 0, no matter what the coefficient is. Okay, so then next up, I'm going to go ahead and draw I'll draw my dots here. So we're all open circles here because it's just less than 0. And then I'm going to remember here that we have a degree 3, and it's a negative. So whether you look at once again, at the standard form or the factored form, we see that our factored form, we have 3 single exponents, so that's going to add up to 3. Or in the standard form, it's the biggest exponent is 3. So degree 3 negative means that we're going up to the left and down to the right. We see all of these x-intercepts are cuts, so I'm going to cut through the x-axis, cut back up, and then cut back down. So we have a positive out here, a negative in here, and then positive and then negative, depending on whether we're above or below the x-axis. And on this one, we have less than 0, so we want the negatives. And so we want the space in between here, and we want the space over here. So my interval notation for this one would be from -4 to 0, and then from 3 to infinity. All right, next up here, this expression is actually not in factored form. This is actually going to require us to do some u substitution here. So I have a weird thing in parentheses showing up twice. So I am going to let u equal y plus 2. And if we do that, then this is going to look like y to the 4th, u to the 3rd, plus y to the 5th, u to the 4th. I'm now going to GCF. We can GCF y to the 4th and u to the 3rd. Which leaves me with 1 plus yu. I can now plug that back in, plug in my u's, and so I'll do that over here. So we have y to the 4th still, and then times y plus 2 to the 3rd, times 1 plus y, and then a bracket y plus 2. So I need to distribute this in here. This becomes 1 plus y squared plus 2y. And then we'll go ahead and rearrange that, y squared plus 2y plus 1. That looks like it can factor, so I'm going to factor that thinking of two numbers multiplied to 1 and adding to 2, which is 1 and 1. So I can actually write this as y plus 1 squared instead of write y plus 1, y plus 1. We have y to the 4th here, and then we have y plus 2 to the 3rd. So this would be our fully factored form. And so now what I'm going to do is I'm going to go ahead and go to my number line here, and we're going to have on there, we have -2, we have -1, and we have 0. Those are all closed dots. And then I needed to look at the degree here. I really only have the factored form, so I have to add up the degrees here. So it's going to be a degree 4 plus 3 plus 2 would be degree 9, positive. So we know our end behavior is down to the left and up to the right. Now, what's also interesting about this one is that we have some kind of odd and even degrees. And so I know at -2, since we have the odd degree, that one is going to cut. But the other two coming from even degrees are going to bounce, coming from the 4th degree and the 2nd degree, respectively. So up here, I'm going to cut through the x-axis, and then I'm going to bounce off the x-axis, bounce off the x-axis like that. Now this is really going to change things for us because you can see here we have a negative down here. This will be a positive, and then a positive, and then another positive. So when they ask us a question like number, or part A, where is this less than or equal to 0, okay? The less than or equal to 0 would be over here. But then it would also be at each one of the x-intercepts, because even though at the x-intercepts it's not below the x-axis, it is actually at the x-axis. So for part A here, my answer would be -infinity to -2 with a bracket. And then I also need to include 0 as an individual number, and oops, I messed that up. -1 as an individual number, and 0 as an individual number. I have to put those in order. I don't want -1 to 0 as an interval for this because I don't want the space in between there, because you can see it's positive. But I do want -1 and 0 as individual numbers. So that's how I show that. So that would be my answer for part A. Okay, I can use this same graph. I do not need to do this all over again when I do part B. So for part B, this is where I want everything at or above the x-axis. So that is actually this whole space over here. There's no breaks in that space because you can see every number from -2 to infinity is either at the x-axis or above the x-axis. So I'm going to have multiple kind of groups there, but I want all of them, and I'm going to connect all of them with one interval from -2 to infinity. I need to do that because I shouldn't be showing any breaks because there are none. All right. Now next up here, we can do where is this greater than 0, and for that I'm going to redraw this since I drew the dots there. So -2, -1, and 0. It's going to be the same drawing except that we have open circles now. So when I want the greater than 0, greater than 0 means just above the x-axis. So I want this interval, I want this interval, and I want that interval. So I want all three of those. So that's going to be from -2 to -1, from -1 to 0, and from 0 to infinity. I can no longer combine those because I need to skip over those individual numbers. And then for this last one, the less than 0, it's this space over here only. I don't want any more of the x-intercepts anymore like I did on part A. So I just want from -infinity to -2 only. All right, next up here we have rational inequalities. So the first step has to be the same on these ones. We will always subtract or add everything over to one side to get one side to 0. So now I'll have 1 plus x over 1 minus x minus 1 over 1 is greater than or equal to 0. So now I need to get a common denominator here. So I'm going to multiply by 1 minus x on this side. I don't really need to multiply the other side by anything. You could do 1 if you wanted to. So that'll give me the common denominator of 1 minus x. And then the numerator, I have 1 plus x from the left fraction. The right fraction, I distribute a -1, so that's -1 plus x. And so if I combine like terms up top, that is 1 minus x over 2x over 1 minus x is greater than or equal to 0. I still need to do that number line thing at this point, and so I said on the first page that you need to put on the number line any numbers that make the expression 0 or undefined. So I'm going to put 0 on top, and I'm going to put 1 on bottom, because the 1 makes the denominator 0, and the 0 makes the numerator 0. So for this one, you're doing all numbers that make the numerator or denominator 0. Now, for dots here, I am going to have a closed dot at 0, which is probably what you would expect, but I'm going to have an open dot at 1. Why am I going to have an open dot at 1? Well, any numbers that come from the denominator will always be open dots, okay? So if it makes the denominator 0, it's going to be an open dot every single time. Why is that? Well, remember that if it makes the denominator 0, that's an undefined value. It's a restriction in the domain. So I cannot include the number 1 in my answer on this problem because 1 makes the expression undefined. Okay, so now I can actually graph this the same way. I need to identify what the degree is here. I am going to say that this one is a degree 2. Degree 2 because we have that 1x in the numerator and 1x in the denominator is how you're going to look at that. So you kind of just look at the numerator denominator separately. If those were on their own, the top would be a first degree and the bottom would be a second degree, and so just add those up separately. I am going to say that this one is a negative though, and that's because we have a negative x on bottom. So if we have one negative x anywhere, that's going to kind of make it negative. And so this one's going to be actually an upside down parabola, like so. So the negative is down here, positive up there, negative down there. This is greater than or equal to 0, so we want the positive. So this one's going to be bracket 0 to 1. All right, next up, number 11. So I will subtract the 2 over x minus 1 here to the other side. So we have x over 1 minus 2 over x minus 1. We'll go ahead and multiply this one by x minus 1 over x minus 1. And so then we'll have x minus 1 on bottom here. We'll distribute this, so it's going to be x squared minus x minus 2. I think we can factor that, so I'm going to think of two numbers to multiply to negative 2 and add to negative 1. So that would be negative 2 and positive 1. And so that's going to give me here x minus 1, x minus 2, x plus 1 on top, and that's less than 0. So now I'm going to go to my number line. So my number line on it, I'll have negative 1, I'll have positive 1, and I'll have positive 2. These are actually all going to be open dots. Since it's just less than 0 in this case, the numerator ones would be open dots, and then the one from the denominator would be an open dot either way because it is in the denominator, okay? Now, what is the degree here? Well, we have 2 parentheses up top to the first power, 1 parentheses on bottom to the first power, so I'm going to say that's a degree 3. And then it's positive because all my x's are positive there, so it's down to the left and up to the right. And so we'll just cut through there. So we have our negative here, our positive there, our negative there, and our positive there. And then we want this to be less than 0, so we want the negatives. So I'm going to say that as this space over here is negative, and in here, so negative infinity to negative 1, and then from 1 to 2. All right, last up here, we're going to do some absolute value inequalities. So for this one, we actually don't need to do that whole the whole graphing thing anymore. So all we're going to do is follow these instructions. We're going to isolate the absolute value, which you can see is already done, split into 2 inequalities. And so I'm going to do that here. So the first one, you keep everything the same. The second, oops, that's a 4. The second one, I always say, change nothing on the inside and change everything on the outsides. So you can see that I made the greater than or equal to a less than or equal to and changed the 4 into a negative 4. So now I just need to solve these individually. So 3x is greater than or equal to 2, and then divide by 3. So x is greater than or equal to 2/3. And then over here, 3x is less than or equal to negative 6. So x is less than or equal to negative 2. So now I'm just going to draw these on the number line. So I have negative 2, I have 2/3. I don't need to do the whole graph, but I just see here that it's less than negative 2, so that's that way, and then greater to 2/3, so that's that way. So sometimes these will point at each other, and sometimes they'll point away from each other. Just kind of trust what the alligators, the greater than and the less than say. So you can see on this one, it's less than negative 2 and greater than 2/3. So this one's going to be negative infinity to negative 2, and then 2/3 to infinity. All right, once again here, number 14 is ready to get split up. So I'll do one where I just take away the absolute value and keep everything the same. And then the other one, I'm going to change everything on the outside, but nothing on the inside. Okay, so now I'm going to add the 2 over here. So 6 is greater than negative x. We'll divide by negative 1. So negative 6 is less than x. I do have to flip the sign there because I divided by a negative. Okay, so over here then, add the 2. Divided by negative 1, which again means flipping that sign. Okay, so now I have negative 6 and 2. Okay, so it's actually kind of written backwards here. If you read it this way, it's actually saying x is greater than negative 6. If negative 6 is less than x, that means x is greater than negative 6. So that would be kind of pointing this way. And then if x, same over here, 2 is greater than x means x is less than 2, so that's over here. So in this case, we're meeting in the middle, and so it will be negative 6 to 2. All right, sometimes these absolute values don't come isolated, so you're just going to isolate them. So I'm going to subtract 20 over here. Oops. I would never distribute a negative 2 into an absolute value. I would never distribute anything into an absolute value. Instead, we're going to divide by negative 2. Now that does mean here we need to flip the sign. So I'm going to split that up now since I have my absolute value isolated. So 2x plus 3 less than or equal to 6. So just take away the absolute value on the first one. Second one here is greater than or equal to negative 6. So I change everything outside again and keep everything inside. So then I'll solve these. So subtract 3. 2x is less than or equal to 3. So x is less than or equal to 3 over 2. Over here, 2x is greater than or equal to negative 9, x is greater than or equal to negative 9 over 2. Okay, so then on our number line here, we have negative 9 over 2, positive 3 over 2. It's greater than negative 9 over 2, less than 3 over 2, so that's in between. So negative 9 over 2 to 3 over 2. All right, and then last up here, number 16, so I'll subtract 20 over here. 2 times the absolute value of 2x plus 3 is greater than or equal to negative 12. We'll divide that by divide that by 2. So we're saying absolute value of 2x plus 3 is greater than or equal to negative 6. And I'm actually going to stop right there because I see something kind of special here. So whenever you have absolute values and this ends up, when you isolate the absolute value and this ends up being a negative over here, it's going to be a special case. So if I kind of think about this logically, when is an absolute value going to be greater than or equal to negative 6? When is the absolute value going to be greater than a negative number? That's going to be from negative infinity to infinity. I don't even need to do any more work there. If it asks me when is it less than a negative number, I would say no solution. I would say never. But if it's greater than negative, that's all real numbers.